So welcome to those of you online. So I know the camera is there, I have to remember that. So I have 8 of my colleagues here in the room, and I'm really glad to see so many of you connected online. So for this presentation today, warm welcome, first of all, to this public lecture on strategies and practices for eco-efficient and circular industrial systems. And before I go into this lecture, actually, I would like to take a moment and ask you to look around you at the things that are surrounding you and count how many of the items have been made in a factory, how many of the things around you are manufactured, and how many things have not been made in a factory. How many things have not been made in a factory? Maybe. I don't even see a tree by the window, right? So if you're like me, unless you're sitting outdoors in the garden, or if you are on a boat in the middle of the ocean, basically you are surrounded by built materials, by built environment, by manufactured goods. And my next question is, how many of those things could you make yourself? Can you find a few of those manufactured items you feel you could make yourself? Yeah. Maybe I could make a table, maybe it wouldn't be that flat. Maybe I could learn glasswork. I think I could make clothes, maybe not as nice as this, right? But overall, if you look around you, you are surrounded by the impact of industrial systems, right? So we cannot live without those industrial systems. We wouldn't have the quality of life we have now. And we tend to forget it. So my colleagues in the room, just the 8 of you, I know you work with those systems almost on a daily basis, but how often do you think about the impact of those industrial systems in your everyday life? Not so often. So in the next 30 minutes or so, my aim is to share with you my enthusiasm for sustainable production, because I think manufacturing things is as close as we can get to magic. And the second thing that I would like to do is to share with you my optimism for the future, both for manufacturing, but also for society. And in order to do this, I have a presentation in 4 parts. So I hope you'll get excited about this journey. I will start with some sustainability concepts that are fairly well known already. But I will revisit them a little bit and challenge them, because that's what I like to do. I like to challenge those concepts and get them to go further. Then those concepts, I think they are grand ideas, but in order to make an impact on the world and change the world, we need to translate them into actions. So the second section of the presentation will be, how do we go from concepts to practices, and specifically industrial practices? And then the third section of the presentation will focus on the tools, the methodologies, the technologies that can assist us in those practices. And finally, in the fourth part of the presentation, I will talk about from less bad to more good. And I will touch on regeneration already when I talk about the concepts. And at the end, I will go back to this after we have heard how we make those things happen to leave us with a positive outlook for the future. So, are we ready? Does that sound like an interesting journey? Yeah? How about you online? Do you like hearing this? Do you want to follow me there? Yeah? Fantastic. So let's get us started with the concepts. Now, sustainability has many different definitions, and today I will go with one of the very classic representation of sustainability, also known as the triple bottom line, or the 3 Ps, represented by those bubbles of people, planet, profit. Now, what is quite interesting on this diagram, you will notice that I have put profit on the foreground, because we are going to focus on industrial systems. And of course, for businesses, profit is very important. I mean, if they don't make a profit, they will run out of business. And no matter how good their intentions are, if they run out of business, there's not much good they can do for the world. So profit is the preconditions for them to survive, right? And if I ask you the question, how is industrial development aligning with economic development? Or how did industrial development contribute to economic development? I don't think you need to be a historian to know that the relationship between those things is very positive, right? We can think about the industrial revolutions. And if we think about how it has contributed to social development, so thinking about people, I just mentioned how good our lives are thanks to all of those industrial systems. And we can do better for social development. We can do a lot better in how we treat people in factories, along supply chains, in communities around where we have industrial activities, especially in the poorest countries. This is where we have a lot of space for improvement. But I like to believe that mostly the relationship between social sustainability and industrial development is largely positive. Right? It helps us have a better lifestyle, healthier lifestyle, better quality of life, let's call it. Now, if we talk about environmental sustainability, now, that's the question that I'm posing here. How can industrial development contribute to environmental protection and regeneration? I think for a lot of people, this is an awkward question, right? We don't really think that industrial systems are contributing to the environment in any positive ways. That's not how it works. And I would like to challenge that. I think it's not right. So we always think about how we deliver positive value for businesses, for people, but the environment, it's always a negative cost, right? As I said before, economic and social, largely positive, but for the environment, it's entirely, maybe almost entirely, I can make some exceptions, but it's almost entirely negative relationship between industry and the environment. I know that the definition of good business has changed already for quite some time. And we know that in order to have a good business, you need to address sustainable development. So we need to both have something that is good to make profit, deliver value for people, but also we are starting to see a shift for how we impact the planet, and especially around climate change. So we still accept the fact that we will have a negative impact on the planet, but we will not accept having a dramatically really bad impact on the planet. So there's a shift that is starting to happen, but I would like to go further. We need to think about how we also deliver maybe zero impact and positive value for the environment as well. So there's another representation of sustainability that I also see increasingly being used. And I think it's also a very good shift that I see that. I know that those of you who work with the topic of sustainability, you will have seen this alternative representation of the triple bottom line. And here we have concentric circles. And I think what is quite interesting with this representation is that it shows the relationship between those three dimensions of sustainability. So we don't have just overlapping circles. It's not like three different systems that are not connected and we try to force the connections. They actually are embedded systems. And if we want to have a healthy economy, we need to have a healthy society. And if we want to have a healthy society, well, we need to have a healthy planet. We need to take care of our living conditions. So you may remember the original diagram that I showed before, where you had profit first, and then people, and then the planet. Maybe it's time that we reverse that order, right? If you want to make good profit, it will have to be basically fitting the rules of society, treating people right. And in order to take care of people, we need to take care of our living environment. So maybe first is the planet, and we need to live within those boundaries in order to have a good society. And all of our economic activities should fit in a human society. Yeah, I hope that makes sense. So next time you have to represent the triple bottom line, I hope you shift away from the Venn diagram and go to this one, because I think this one captures a much stronger view of sustainability. So this was for the concept of sustainability with a triple bottom line. For this presentation, I'm going to focus on industrial systems. So I will replace the economy bubble with industrial systems. And I will make a little bit of space because I would like to map something else, because I'm going to talk about eco-efficiency and circularity. And therefore, we need to represent resource flows. So I'm going to rely on industrial ecology here for representing the different ways resources are flowing through our society and our industrial systems. And actually, it feels a bit like going back to my roots, because I've done my master's degree on industrial ecology here at Chalmers 12 years ago now or something. Ooh, that starts to make me feel a bit old, right? So with industrial ecology, we have this typology saying that there are three types of flows, with the first one being linear flows. So it's like the take-make waste, which originally, before the industrial revolutions, was okay because our rate of consumption was much lower. Not only did we rely on bio-based materials, but also we were basically using local resources fairly slowly. You would have a pair of shoes you would wear until they would have holes in them. And by the way, if they didn't have holes, you would pass them on to your siblings, right? So we had a slow consumption. And the amount of waste and pollution we were generating, unless we were in very densely populated cities, were something that could be assimilated by the planet, right? So because this linear flow was so slow, it was sustainable. Now, with industrial revolutions and with our technological development, we have accelerated that linear flow to the rate where we are exhausting natural resources and creating pollution and waste accumulating in our environment and creating issues. Right? So we're accumulating a lot of ocean plastic, we're accumulating a lot of carbon dioxide emissions in our environment, creating the impact on our climate. So there are lots of issues, right? So what we have seen in the last few decades is a shift to quasi-cyclic flows. And this is where we start having a bit of recycling. So, for example, we start to recycle paper and glass and metals, plastics. That technology is getting better and better. But quite often when we recycle, we still lose a little bit of value. That's why the flows are not completely closed. And some other people see this a bit like a downward spiral. So we lose some value in the material. So it's not closed loop, it's open. But as technology is getting better and better, we are also seeing cases where we are able to recycle materials to the same level of quality as brand new. So we are able to reuse the materials for the same applications. So that is the case, for example, for plastic bottles. Now we are able to recycle some of the plastics so well that it can be a perfectly closed loop system. Perfectly closed loop, but that's not quite right. We still have some laws of nature or laws of thermodynamics to work with. So it's not entirely perfect. And industrial ecology actually has its name with ecology, with this biological analogy in there. And it makes the argument that we need to shift away from model 1 and go to the model 3 of flows. And that is this biological analogy, where we say nature functions in this very cyclic way. So we indeed have waste becoming a resource for another system, right? And that's what we try to do. Now, a problem with this idea is that a lot of people perceive these cyclic flows as the concept of perfection. So we are not able to be fully cyclic. And I just mentioned the limits of thermodynamics, for example. So we have a bit of a mental block in how far we can go with cyclicity and that we can never reach this perfection. It's a little bit similar with zero impact or zero waste or zero emissions as well. We have this tendency to perceive this zero as perfection. And actually, it is true, it can be really hard also to achieve this zero impact because we don't really know what is the baseline. Zero compared to what? Zero compared to if the factory didn't exist, or it's very hard, right? So in order to overcome this challenge of this mental block about we cannot reach perfection, I would like to propose a fourth flow. It's not good enough to aim for zero. Maybe there's a way to be positive. Now, this fourth flow, I called it regenerative flow, and it is captured with the concept of circular economy and as well as industrial ecology. So it's not completely new, but I'd like to visualize it. So to help us have this mental model on how we can shift our society through resource efficiency towards environmental sustainability. Now, when I present this fourth flow, people sometimes think I'm a little bit crazy. It's like, we're not going to landfill to the landfills to find our resources. We're not mining landfills, right? Well, actually, we are to some degrees, not always in a very good way. We need to think about how we do that better. But we also have seen some initiatives where we are fishing ocean plastic, right? We have seen also some cases where factories are able to regenerate resources. So I have seen someone connected here with a grand example about a wastewater treatment in a factory where the water coming out of the factory is so clean that they're basically cleaning water. They're cleaning rainwater, they're cleaning the river water. So they can regenerate resources. We can also do that with air. We can create clean air for industrial systems because the technology is that good, right? So this is not completely crazy. We are actually doing it. So I hope that this figure helps you get a sense of direction. So this is the direction we want to take. We want to move away from these very high, fast consumption rates and this very high, fast generation of waste to something that is more cyclic, more eco-efficient, and maybe even regenerative. Now you may be wondering, these are all grand, nice concepts, but how do we do that? So let's move on to the second section of the presentation. And I would like to talk about the practices. And I think it's quite interesting when we talk about sustainability or circular economy. We have these grand visions about what products could be, what impact they could have on our lives. And I really love this cartoon here from Harris in the Scientific American Scientist. And this cartoon captures this idea that we see manufacturing as this miracle that occurs in the middle, and we don't always think about what happens in that black box, right? So we have an idea of a product, and it's going to have a great impact on our lives. And then we think about how we can close the loop. But what actually happens in our industrial systems to make that happen? we need to unpack it. So let's unpack this box. And in order to do that, I would like to turn to my good old friends that I've been working with since my master's degree, when I was doing my master thesis at Toyota, and then again when I was doing my PhD in Cranfield, and then again during my postdoc in Cambridge working on eco-efficiency. And those friends are the waste and energy hierarchy. So for those of you who work with sustainability, you probably will have seen both of them, but those who do not work with sustainability, you'll still very likely have seen this waste hierarchy, pretty famous friend. Now, at the top of this waste hierarchy, we have avoidance. So whenever possible, we want to eliminate the use of material. And I think digitalization is a great way to do that. So going paperless, think about digital services as well. So there are lots of things that we can dematerialize in this way. The next layer is about reducing our waste. So again, going with dematerialization strategies, you can think about packaging. Maybe we can make it thinner. We can have lightweight structures. We can also have multifunctionality. So if you think about this device here, it's a camera, it's a notebook, it's an alarm clock. Oh, by the way, it's also a phone. Almost forgot about that, right? So we can have multifunctionality. So for every single unit of material I use, I will have more value. Then if we cannot reduce the amount of material we use, we can start thinking about, okay, at its end of life, what can it be? So maybe I can reuse it, repurpose it, or worst case scenario for circular economy would be recycling. So you will separate the material and try to find new applications for them. Then if we do not have the technology for closing the loop, maybe we need to think about how we treat this material in a sensible way. So we need to think about the toxicity for humans, toxicity for the environment. We need to treat our waste and dispose of it in the right way. And finally, at the bottom of the waste hierarchy, we have these energy recovery and landfill options with that, which are basically the undesirable options. So energy recovery is basically incineration, where we recover some energy from the burning of the waste. Now, if we turn to the energy hierarchy, this energy hierarchy actually could be renamed as a carbon hierarchy, because it's in effect looking at how we can reduce our energy-related CO2 emissions. And at the top, again, we have demand minimization. So basically switching off things, avoid using electricity when you don't need it. Then we have energy efficiency. So think about shifting to LED light bulbs, or when you buy a fridge, usually you have these energy labels, right? And we're getting better and better at energy efficiency. That's why we have the label A and then A+, and A++. We keep on adding pluses because we are so good at this. Then we have renewable sources. So if we cannot reduce our use of energy, we need to find ways of reducing the carbon intensity of our energy. Renewable sources, of course, are the best choices, like solar, hydro, wind power, geothermal power. And in some cases, we still need to rely also on other resources because our energy demand is so high that we are not able to meet the demand with renewable energy systems yet. I'd like to think that this will grow fast. So we can look at low carbon technologies. And here you can have things like nuclear or biogas, for example. These are considered as low carbon or lower carbon, if we use a comparison. And finally, at the bottom of the hierarchy, again, we have some less desirable strategies with carbon offsetting, so capturing carbon, putting it underground. But you also have some slightly more positive ways of doing carbon offsetting, like planting trees, and that aligns with regeneration as well. And finally, at the very bottom, with conventional energy, it's basically fossil fuels, like coal and oil. Now, one thing that I don't like so much, you may have heard in my description of the hierarchies, is the fact that you have those undesirable options at the bottom, meaning that you may feel like, okay, I have tried all of those improvements at the top and I'm stuck. I don't have anything else that I can do, so I'm left with those bad choices. So during my PhD, I've been collecting a lot of practices for resource efficiency in manufacturing, and we use instead this improvement hierarchy, and it brings energy, material, water, and any other kind of resources we use in factories together. And it's an improvement hierarchy because there are no bad choices in this hierarchy. You can see the bottom layer here actually is still something positive. So again, at the top, as I said before, we still have the prevention, avoid using resources whenever possible. Then we want to look at waste. So especially with the concept of lean, we know that we need to look for waste and eliminate it. And then we can look also at the resource inputs into our processes and think about how do we work with efficient processes in order to deliver the product at the right quality. Then if we still have waste, we can look at the value of that waste and see, can we reuse it locally or maybe send it to recycling so we can still have some value recovered from those materials. And finally, at the bottom, you have the substitute, upgrade or replace, where we are basically saying that if you cannot do any of the top improvements, maybe you can look at maybe the function of your system or what it is that you're trying to do and think about doing things differently. So for those working with business research, quite often you will call that innovation or radical innovation. Or maybe just look at the wider system. Are there wider system improvement you can do? So this is the improvement hierarchy. And to get a bit more a concrete idea of how we put that into practice, I'm going to give you an example on a process. And it's going to be a very simple process here. Let's say it's going to be a drying process. So we have a product that has been coated with some kind of paint or some kind of treatment, and we're putting it into an oven in order to dry it and achieve the right product performance, so the right product characteristics. Now I'm going to capture the energy consumption of the process and the surrounding systems. And at the bottom, you have this production volume that shows how many products are in the oven at any given time. And this is a very simplified version of a process we investigated during my PhD project. So it's loosely based on this. And the first thing we need to do at the top is to prevent the use of energy whenever possible. So you can see in the early morning, during lunch or during the evening, there may not be any product in the oven. So maybe we can switch off. Now you can see that I'm not going all the way to zero, because in factories, we usually have also some processes that need to remain on. So we have like a base load of energy. So imagine a little bit like your freezer at home. You cannot switch it off even when you go on vacation, right? So it could be for safety purposes. It could be because materials are condition sensitive or many other reasons. But we need to look at ways we can power down at least. So maybe there's a standby mode or low power mode that we can engage. So that's for the top improvement, switching off or powering down. And the next set of improvements is about looking at the waste. So maybe in this oven, we have some waste energy, maybe some heat that is evaporating in some ways or leaking, maybe some air leakage in some corners or where the door is. So we can think about insulating the tank thermally, making sure that the air is not leaking out of the oven. Some pretty simple fixing just to make sure that we reduce the amount of waste in the process. Then the reduced resource use. This is probably my favorite set of practices. And also would like to call this one challenging the set points. So maybe we can achieve the same dryness or the same product performance or product quality by lowering the temperature a little bit or lowering the airflow. So maybe we don't need to consume that much energy and we achieve exactly the same quality. We can also think about recirculating maybe some of the air. So instead of just opening the door and letting all of the hot air escape, maybe we can find ways of recapturing that. So that would capture also the reuse waste as a resource. And finally, for the last strategy with substitute, upgrade, replace, here we are looking at maybe installing some controllers on the process. So maybe it will automatically switch on in the morning and avoid this big peak of power in the beginning. So you can more slowly reach the same point in a more energy efficient manner, but also adapt exactly what is needed in the process by having some sensors in the tank. So we know exactly how much energy needs to be brought in order to reach the set points. And so after applying this improvement hierarchy, we should have this bottom green line of energy profile. And the difference between the red line and the green line is in effect waste, right? So I hope this gives you a bit of an idea of how we can implement the improvement hierarchy on the process. And I think that what is quite interesting in my case is when we start a project, quite often we tend to be a bit shy in the targets that we set for energy reduction. So typically we'll be like 2, 3, 5%. If we're daring, maybe we'll go to 10%. But in that particular process we looked at, we save close to 80% energy on that process. Okay, so it's not marginal improvement. It was really big improvement. And by the way, the process had no problem whatsoever. It was working perfectly fine. Right? So we had a mindset, because it works, it doesn't need to be improved, we're fine. But actually, if we look at our processes closely, we will always find improvements, even the best in class. And we've done this project with the best in class, and they constantly find improvements. So if the best can do it, I think everybody can do it. So this was for the practices. Now I would like to move to the third section of the presentation to think about how we can use technologies, methodologies, and various toolboxes to help us achieve this success that I call sustainable performance. And to do this, I've been developing a toolkit that is called a Eco-efficiency Toolkit over the past few years, and with a lot of collaborators. So many of you are actually in this room and online as well, you have contributed to this toolkit. And you are basically saying that for eco-efficiency, there are 5 types of activities we need to do. The first one is to learn to see waste, and very importantly, learning to see the value embedded in waste. And that is not always as easy as we think. It's not just like the waste accumulating in a bin. A lot of that waste is invisible. Right? So for those of you, again, working with Lean, you know the Muda waste, Muri, and other forms of waste, they are not always visible. But even for physical waste, quite often it's hidden in pipes, or is going to be waste heat, can be noise as well. So there are a lot of different forms that we don't think about. Once we have identified that waste and we know its value, we need to find solutions. So that's the second type of activity, finding solutions. And here we can use the waste and energy hierarchy and the improvement hierarchy. We can use best available technologies. We are constantly improving. So I really think we have a vast array of solutions out there. Just needs to, sometimes we need to look hard enough and we will find them. Then the third type of activity is about assessment. So for environmental impact assessment, I think the best tool at our disposal is life cycle assessment. Now we have seen that for manufacturing companies, it's sometimes very hard to use that tool. But we do have, again, a vast array of tools for impact assessment, and we need to use them because we usually improve what we measure. And if we don't measure our environmental impact, we don't tend to improve it so well. So what we consider as being performance indicators are what we will optimize. So let's bring environmental dimensions in those definitions of performance. Then the fourth type of activity is about setting ambitious targets. And I'm emphasizing here ambitious. As I mentioned before, we should not be too shy in setting up targets because if you aim for 2-3%, you will need that and then you'll relax, right? I've met my targets for this year, happy. If you say 10%, very likely you will reach 10%. And if you say, I want 50%, maybe you'll reach 45. And if you say, I want to be zero impact, you'll be fairly close to it eventually. So I believe that we have ingenuity. That's our strength as a human species. We have ingenuity. If we set ourselves ambitious enough targets, we will work really hard to get there. So let's not be shy and set up ambitious targets. And finally, fifth, last but not least, is going to be continuous improvements. And here we need to think about how we develop the right organizational structures or the right processes or procedures around those 4 activities so we can bring them into business as usual. Because we've done some really fun activities, like, for example, eco-efficiency treasure hunts for learning to see waste and find solutions. And it's great to do those things. But what if you make those improvements today while you do those gamified activities, but tomorrow you forget about it and you fall back into bad practice? In order to not fall into bad practice, you will need to have some procedures in place. So you make sure you capture those improvements and keep going. So we also need to measure your performance, right? So you have a benchmark. How did we do yesterday? And how do we make sure we do better tomorrow? And we would like to have also some great targets to drive those improvements forward. Now, I also promised you that I would talk about technologies to do this. So I'm going to give you a few hints about how we can use digital technologies to do that. And for the first one with the treasure hunts, yes, we can rely on our sensors. As I said, we can go around and I can hear some air ventilation over there. So that's probably consuming energy. I can feel like it's quite cold in this room. So we have air conditioning. So I can use my senses to get a sense of where energy is being used. But I can also use thermal cameras, for example, or smart sensors. So nowadays with those big digitalized systems, we have access to a lot of data to better understand how our systems are working. And we can find where waste is. We can also use modeling and simulation in order to see, compared to thermodynamic models, how much waste do we have? Can we go closer to thermodynamic minimums? So pretty advanced modeling and simulation tools as well. Then for finding the improvements, so we have my colleague here working with artificial intelligence. We have great tools to help us assist in identifying some improvements, especially with all the data we have. And in some cases, we don't have the right data to assess environmental impact. So I think we can be better in terms of collecting environmental data. But we have great tools if only we measure the right things. Right? We will improve what we measure. So we also need, whenever possible, to adapt a life cycle perspective to make sure that we don't have unintended consequences or what is called the rebound effects So maybe we do a local improvement here, shifting the material we use because it's more efficient in the process, but maybe that material has a bigger environmental impact on the supplier side, right? So using our data to have a systems view on our performance. Now for setting targets, as I said, I really think that if we set ourselves some really ambitious targets, we will dare more, we will innovate more, and we have the technology for it. And for systematically improving our systems, this is where I think there's a lot of exciting developments in terms of Internet of Things, industrial Internet of Things, or IT systems to support operators. So now we have great information systems to help us bring all of those procedures and support people so it can be part of business as usual. So if we bring people the right information to make the right decisions in manufacturing, including environmental aspects as one of the criteria for optimizing our systems, I think we will do it. But now we're still largely focused on cost, quality, meeting customer requirements on time, right? Sometimes we do have efficiency included, but mostly from a cost perspective. But imagine what if optimization models had environmental aspects included in there? What if? I think we will manage. So this is a toolkit for eco-efficiency. Hopefully giving you some food for thoughts about how we can make those things happen, apply the improvement hierarchy, go further with the resource efficiency. So now I'll move on to our fourth section of the presentation and talk about how we can do some good, like proper net positive good with regenerative sustainability. And to do that, I'll go back to that very colorful pictures that I use for introducing the concept of sustainability. And remember that fourth flow of regenerative flows, right? Hopefully feels a little bit more tangible now. You understand how we can do it. Doesn't sound easy, I know, but bear with me. Which of those four flows do you think is the least sustainable? Super easy question. Which flow is it? Can you show me with a finger to think about the number? Yeah, how about online? I'm looking at you. Yeah, I see a lot of you. Yeah. So the least sustainable flow is the linear flow, right? Now, I would like to confuse you a little bit. What is the difference between this linear flow and the cyclic flow number 3 that is open and goes back to the environment? So think about food waste, for example, that we put in the compost. What is the difference between that open cyclic flow and the linear flow? Maybe some of you are thinking about it. I'll give you a few seconds to think about it because I think it's a very, very important difference. In the cyclic flow, we consider the environment as part of a system. In the linear flow, we say we are human systems, industrial systems, and nature is external. That's the only difference. Honestly, it's the only difference. So actually, if we start seeing nature as part of our industrial systems, actually linear flow may not be all that bad. As I mentioned, we have the technology to be incredibly efficient, incredibly cyclic. We have access to wonderful data to understand where waste is and how we can do better. So imagine if we had all of that technology applied on making this linear flow fit with the planet. We can be so efficient that we will consume resources at a lower rate than it can regenerate. And that has the precondition, of course, that we source our material from renewable sources and that we consume it with care about regeneration rates. But we have the technology to be incredibly efficient, so I think we should aim for this. How about the waste and the pollution that we generate? Once again, we need to consider what is it that we release to the environment. Can our waste and our pollution actually be okay? And CO2 emissions per se is not that bad. The question is about the concentration and the speed at which we emit all of those things. Same for nitrogen or phosphorus. We have a lot of different substances that we emit. And the reason why it is waste and pollution is because of the rate at which we emit it. It's about the concentration and the speed. But what if we were able to treat our waste so that it doesn't have a harmful effect on the environment? What if we had such a good understanding of our planet, which we have, by the way, we have great environmental science, so that we understand what is the assimilation capacity of our planet so we don't exceed that. So those of you who have heard of the planetary boundaries, that's exactly what I'm talking about here. We have a fairly good understanding. Now, not perfect. There are still ways the planet works that we are not fully aware of, right? So it's not perfect. But we could operate within the boundaries of this planet using the technology for that purpose. So we need to rethink our industrial development and our technological development to achieve this. because I believe that we can. We have the ingenuity, we have the creativity, we have the power for it, right? So I hope that I'm giving you a message of positivity here, so I can share optimism, because I really believe we can do those things. Maybe we won't be able to do all of this now, right? We will still have a mix of all of those flows. That's why I really like this representation rather than the typical linear or cyclic. Actually, we have all of those flows. Our world is so complex. But let's think about the direction of change and how we make sure that every time we have a new piece of technology or a new innovation, we shift in the right direction, right? So digital technologies should not accelerate the linear economy. That's my plea for you. So I would like to recap a little bit what we've heard today and turn to you with a question, because I think we've heard a lot of things, and I hope you had a few things that went in your brain, aha, I can do this, right? So I've been talking about 4 things. First, about concept for sustainability, and I revisited them a little bit, hopefully giving you a fresh eye on them. Then we've talked about how we translate those great ideas into action with examples of practices, and especially focusing on manufacturing practices. And we talked about the tools for success. It can be toolboxes, methodologies, and technologies. And finally, for the 4th thing, I've been talking about regenerative sustainability, how we can actually do some good. And I hope you are with me now and you will not think it's a crazy idea anymore. We can actually do some good. So what does sustainability mean to you? For those online, by all means, write what it means to you in the chat, because I would love to read this later on. But for now, before I finish, I have one last slide. It's the busiest one, so be ready for it, because I think now it's time for me to brag a little bit about all of the wonderful work that I have done with all of those wonderful people listed here. Look at this list. Look at all those people who are fighting with me to make the world more sustainable. And I would like to invite all of you in the room, my dear colleagues here, my colleagues online, my friends online, our industrial partners, all of you to engage with sustainability, because I believe that we can all be sustainability hero. Yes, you can online as well. Everybody can. So join us and be a hero, please. Thank you very much.